Hi guys. So this week we are talking about brain development. I might have to split this into two parts because this is a pretty long slide presentation. Part of it has been adapted from the FAP training done by the Mental Health and Hygiene, which is where some of the information has come from. And I've adapted it to sort of fit into sort of take from it the information that we need. And then I also added some additional components as that one was very much designed around infant brain development. And I wanted to include brain development throughout the lifespan. Alrighty. So, infant brain development, starting at birth, infants have about 100 million brain cells and 50 trillion connections. They are constantly, there's constant generation, constant synapses occurring and happening. The neurotransmitters are developing and multiplying. Those connections are made stronger and stronger. And if you have already watched the attachment video, you will learn that those attachments are made, those connections rather are made stronger by the serve and return, by the responsivity of the parent, by the experiences and the environment can impact the strength and number of connections that are made in a brain. Without those kinds of environments, there are fewer, or the connections aren't as strong, so the brain is unable to return to them or know its sort of pathway in the same way than if they are constantly sort of built and strengthened each time there is sort of this kind of repetitive action of somebody responding to a give and take. At 3 years, the child has twice as many connections as an adult. Now, there is a pruning process that occurs later, but by the time a child has 3, we have had this huge amount of brain development happening. The connections not used will eventually disappear. Okay. So negative, as we also learned in the attachment video, so some of this is repetitive and a bit of a reinforcement. Negative experiences on the brain development, and prenatal and infancy. So prematurity can be associated with differences in brain structure. Deprivation of stimulation impacts developing brain and mental health of the parent. So postpartum depression, a parent who struggles with anxiety. Now that does not, like I said in the other video, that does not guarantee that a child is going to have delays or not positive or not a good outcome. These are risk factors. What will sort of counter these risk factors are other positive adults in this child's life. And that can be childcare settings. That can be the spouse or a partner, a grandparent. That can be someone else who is also supporting this person. Again, more things, additional risk factors, specific toxins can affect brain development, and that is prenatally. So someone who drinks or takes drugs during the pregnancy phase at different points, that alcohol will affect brain development, as some of us have seen maybe in our clinical settings. Fetal alcohol syndrome is something that can occur for children when parents drink at a certain point during their pregnancy or throughout their pregnancy. Child abuse creates differences in the brain also. Maltreated children have typically smaller brains than healthy children. So this is a biological reaction to intense stress. I think what happens, and this is again a theory of my own, that the brain sort of, the body shuts down in order to protect itself. The brain does things to protect itself also from those negative stimulus, and therefore it is not generating those kinds of synapses. Maltreated children often exhibit depression, learning problems, anxiety in childhood, and other problems. When the body is, and this can happen at any age, when somebody is under stress, a toxic stress, that is a increase in the hormone cortisol happens, that's when that fight or flight occurs. When someone lives in a state of fight or flight, which is a normal reaction to situations that our body does to protect ourselves. So when someone's coming at you to attack you, your reaction is to either stand up and fight or to turn and run, right? So, but and that happens in a singular situation many times throughout our lives, right? So we don't have this sort of permanent process that's occurred as a result of that, but someone who is constantly in that fight or flight scenario, someone who's constantly in those types of negative environments, that's going to have an impact on their brain development. Parent-child interactions are what can support brain interaction, as we also heard in the attachment video. So that's why these two things really do go together. Parent-child interactions impact brain development. That serve and return, the responsivity that I talked about in the other video, that sense of attachment that a child has to a positive, those positive interactions that a child has with a caregiver. Parent-child interactions can impact how genes are expressed. Responsive parent-child interactions promote accelerated development of sensory, perceptual, cognitive, and emotional systems. Smiling encourages smiling. An upset child gets someone to hold and love them. There are sensory experiences from music, from toys, from the environment, from the world around us, going outside in the cold, going to the beach, feeling the water on your toes. These are all things that generate and promote brain development through those experiences. Research has shown that parent-child interactions characterized by, here's the word I keep saying over and over again, responsivity, are associated with higher levels of sensory, perceptual, cognitive, emotional development. Parents naming what things are, parents exposing or caregivers exposing an infant or child to a variety of experiences in a safe, contained environment. Responsive parenting leads to secure attachment and improves self-regulation. This is executive functioning. We're talking about that frontal lobe, and that frontal lobe having the ability to take in information and make decisions about that information. And making decisions about the responses to that information. Healthy brain development is supported by interactions with caring people, touch, consistent responsive relationships, positive affect, and healthy environments. Brain development in early childhood to middle childhood. In early childhood, there's increased myelination, leads to an increase in the nerve impulses between different areas of the brain. So we have this increase in the myelination. An uneven myelination growth to various parts of the brain can lead to gaps in process and understanding. So although we continue, there's a definite slowdown during middle childhood. There's a definite sort of slowdown of this, we have this major leap in the first 1 year to 3 years of life. We again have another one in adolescence. It's during these, during the middle childhood years that although there is still brain development, those brain connections are really just getting stronger and stronger. We're not really developing new ones per se, although I'm sure that does happen, but we're really shuffling things around, and we're making which ones are the strongest connections. Variables that affect brain development in early childhood also are going to be nutrition. In infancy, early childhood, through our entire lives are going to be nutrition, stress, the environment, access to learning experiences. So do we have access to good education in schools? Does a child have access to a museum opportunities, playgrounds, school literature, libraries, access to books, and the parent-child interaction, or that should really say caregiver-child interaction. It's not just limited to a parent. It's not limited at all. It is open to any positive, consistent, caring adult. Adolescent brain. Here's where things get really kind of fascinating, I think also in brain development. So in brain development, in the adolescent brain, what happens is you have, again, another boom, huge resurgence of synapses being developed again. So complex changes in the organization and functioning. So everything moves from this sort of frontal lobe to what's called the amygdala. The amygdala is your sort of reptilian part of your brain, and that is a much more emotion-based response, which is why teens struggle with good, with risk-taking behavior. It's why teens sometimes have a difficult time looking at someone's face and determining whether they're angry, upset, sad, happy. Well, maybe not so much happy in that category, but they do have a difficult time sort of distinguishing facial expressions because they're using this. What's happened is that the brain has while it's under construction in the frontal lobe, it's shifted all these things to this amygdala part of our brain, and the amygdala part of the brain is not as highly developed as our frontal lobe. So your frontal cortex, associated with executive functioning, memory, reason, decision-making, impulse control, so that frontal lobe that would stop somebody from saying, maybe it's not such a good idea to text and drive. Maybe it's not such a good idea to skateboard off this building into a into a mattress, or off the roof of my house into a mattress, of which you see all those crazy YouTubers doing, right? That part of the brain is under construction, and they're using a different part of the brain that sort of says, hey, yeah, let's do it. So these undergoes a series of changes. The white matter continues to develop, enhancing communication between the neurons, and the gray matter increases then decreases through a process of pruning. So it's increasing, and then it starts to prune out what it's not really using. And this is a very similar process to infancy. So that's what also happens in infancy. So the brain builds all these neurons. It figures out which ones are the ones that it's going to use, and the same thing in adolescence, the stronger ones, the ones that are being used more often, and then it prunes out those other ones so that the process becomes quicker and faster. And that's what gives us that sort of that response time, as opposed to the brain taking 13 different methods to get to the same answer. It's developed a system of getting to that information faster and quicker. Parts of the brain involved in emotional responses are fully online or even more active than in adults, while parts of the brain involved in keeping emotional, impulsive responses in check are still reaching maturity, often leading to risk-taking behavior. This is what I was talking about before. The frontal lobe, the frontal lobe cortex is under construction, so your amygdala is what's really controlling some of this behavior, and your amygdala doesn't have the capability always to make a good decision, to reason, to control those impulses. It just says, hey, let's do it. So brain development in adolescence, areas involved in more basic functions mature first. Those involved, for example, in the processing of information from the senses and in controlling movement. The parts of the brain responsible for more top-down control, controlling impulses and planning ahead, the hallmarks of adult behavior, are among the last to mature. And if this doesn't explain our behavior as teenagers, I don't know what does. We originally just thought that teenagers were just adults who hadn't fully matured yet, and they're not really. What they've discovered is that the amount of brain development that occurs in an adolescent is similar to that of an infant, and it's amazing when we think about, because it gives you a better and deeper understanding to recognize why teens are doing the things that they're doing and why they just don't get, dude. If you text while you're driving, it is likely you will have an accident or hit someone else and hurt someone else. That does not exist always in the capacity of the adolescent brain. They don't have the tools yet, or the synapses, the part of the brain isn't fully developed yet that is helping them to make those decisions. It explains so much about teen drinking, adolescent drug use, sexual encounters, doing homework, planning the future, looking towards, oh, I can do that again later, I can do that again later. This idea also of being, of being immortal, like it really comes from this, the brain just has not fully formed itself yet. It's super fascinating. So responses to teens' emotionally loaded images and situations are heightened relative to younger children and adults. The brain changes underlying those patterns involve brain centers and signaling molecules that are part of the reward system, which with the brain motivates behavior. These age-related changes shape how much different parts of the brain are activated in response to experience, and in terms of behavior, the urgency and intensity of emotional reactions. I know I'm going on a little long, but I think this is the last slide. So this image also shows, and I think this was also in some of your readings, the way that the brain develops over the course of the lifespan. So what it looks like at a 5-year-old, a preteen, a teen, and then 20-year-old brain, and the types of development that happens, and sort of showing in this highlighted color the way that the responses and the neurons are being developed. And it's so fascinating to me, this new development, because it really does give us a better understanding about how to talk to, respond to adolescents if you're working with them, or if you have a young to emerge, and the brain is not fully developed until like people are around 25. So you could have a parent walk into your child care center with a young infant who has not a fully developed brain, and that's going to be part of your understanding in really supporting and working with that parent, as we have talked about. Or if you are working with adolescents, this is information to have. And how do you present information? How do you provide them with parameters? And how do you better understand what their behaviors are telling you about where their brain development is? And it gives you a whole new tool in order to assess and support adolescents. So I totally love this. I'm fascinated by brain development. I hope this is helpful. If you guys have more questions about it, please post them, put your questions underneath in the comment section. All right, thank you.